In the previous session, we discussed about the induction motors and the principle of operation of DC generators. Now, so this is about the DC generator, how it is there in this diagram, and so a generator which converts mechanical input to mechanical energy to electrical energy, and a motor which converts electrical energy to mechanical energy. So we already discussed which converts one form to another form, either electrical to mechanical or mechanical to electrical, and this is about the electrical motor. So this is a motor generator set. So what is the motor output? So if you take a motor output, the motor output is mechanical output, input is electrical and the output is mechanical output, and this is coupled to the generator. Then if you have a generator, means how many machines we require? 2 machines. For a smaller machines, for smaller generators, we require motor and as well as the generator. So Faraday's law already we discussed. Here he is taking a copper coil and the magnet is moving nearer to the coil and away from the coil. Here the bulb shows the brightness and galvanometer shows positive deflection and as well as the negative deflection and 0. And what are the basic requirements for production of EMF? First one is a magnetic field and set of conductors, and there is a relative motion between the magnetic field and set of conductors. There only EMF is induced. Whenever flux linking with the coil changes and EMF is induced, that is called the Faraday's first law. Whenever conductor cuts the magnetic flux and EMF is induced, Faraday's first law. And rate of change of flux linkages and EMF is induced, that is called the Faraday's second law. So this is about the Faraday's second law. Here minus sign is there, where average value is equal to minus n into d phi by dt. And Lenz's law effect will always opposes the cause. As we have discussed clearly in the transformers, what is the cause for production of the EMF? Flux is the cause which opposes the changes in the flux. And this is about the right hand grip rule. So if thumb indicates the direction of the current, and rapid fingers represents the direction of the flux and vice versa. And this is about the Fleming's left hand rule. As we discussed already, Fleming's left hand rule, stretch the 3 fingers, one is perpendicular to another, and this forefinger represents, this one is called the forefinger. Forefinger represents what? So if you go for the forefinger, so forefinger represents magnetic field. Yes, magnetic field is clearly mentioned that. And this middle finger represents the direction of the current, and thumb indicates the direction of the force here. So here force is the unknown quantity. And coming to the Fleming's right hand rule, so this is motion of the conductor or movement of the conductor, motion of the conductor. Thumb indicates the motion of the conductor. In an examination, you may ask simply Fleming's left hand rule and right hand rule also. Forefinger represents the direction of the magnetic field, and the middle finger represents the direction current induced or EMF induced in a conductor. So what are the basic requirements production of EMF? Already we discussed what is magnetic field. So how magnetic field is required, right? Yes or no? Magnetic field is required, set of conductors are required, and there is a relative motion between the magnetic field and set of conductors. And the principle of operation of a DC generator, which type of EMF it is called? The dynamically induced EMF. So in a transformer, we are using a statically induced EMF. Statically induced EMF, it is a EMF which is induced in a set of conductors which are placed in a time varying magnetic field. If you go for the transformer, so if you go for a transformer time varying magnetic field, so it is called the time varying magnetic field. And the conductors are stationary. Conductors are stationary. But if you go for the DC motor, DC generator, if you go for a DC generator, conductors rotating, so rotating conductors. And flux is constant here. flux is constant. So this type of EMF is called the dynamically induced EMF. This type of EMF is called the dynamically induced EMF. So whenever flux linking with the coil changes, an electromotive force is set up in that conductor or coil. The change in flux associated with the conductor can exist only when there exists a relative motion between the conductor and the magnetic flux, as we discussed already. Okay. So this is E is equal to BLV sin theta. From this only we can derive that E is equal to E max sin, where theta is called the omega t. That's why our sinusoidal voltage, where E is equal to V max sin omega t. Sir, what is E, sir? Instantaneous value of the voltage. We can define the instantaneous value of the voltage at any point of time is called the average instantaneous value of the voltage at different values of omega. So yesterday we already discussed this is the position of the conductors, but we are not representing in the board. So this is a north pole and south pole. North pole and south pole, when it is excited with a DC supply, it acts as electromagnet. If it is a permanent magnet, so if it is made with ferromagnetic material, that is very, very important. So ferromagnetic material. Ferromagnetic material. Okay. And what is this called? Is called the commutator. Commutator which converts, see here, negative of cycle is converted into positive of cycle. Negative of cycle is converted into positive of cycle. And so this is operation with a commutator. How it will be works, right? So the current which is flowing through the load is constant here. The current which is flowing through the load is constant. So the current flows through the load is always constant, and which is flowing through the load is unidirectional only, as we already